All right, so it's about 7:05. I'll start. Hi, my name is Jessie. I'm a freshman, and today I'm going to be talking about the law of cosines and the law of sines. So I have a schedule here. First of all, I'm just going to go over some basic trigonometry in case someone's not familiar with that. And then I'm going to go over the law of cosines. We'll probably do a few practices. Same with the law of sines, and then finally we're going to learn how to practice this when things aren't so straightforward in the problems. Alright, so first we're going to go over some basic trigonometry, just to understand what sine, cosine, and tan all are. So, in a right triangle, we have three functions that we can define, sine, cosine, and tan. So, when we're given a specific angle, we can find the sine, cosine, and tan of that angle. And these are all ratios. So for example, like sine of 30 is going to be the same no matter what the side lengths of the triangles are. So sine is defined as the opposite side over the hypotenuse. So opposite is the side right across from the angle, and hypotenuse is always going to be the side across from the right angle. So this would be opposite, and hypotenuse would be right across from the right angle. We also have cosine of x, if this angle is x, and that is the adjacent over the hypotenuse. So adjacent is the side touching the angle, that's not the hypotenuse. And then finally we have tan, which is the opposite side over the adjacent. If anyone needs to know, tan of x is also equal to sine of x over cosine of x. Alright, so now that we've defined sine, cosine, and tan, let's move on. So yeah, as I said before, these are ratios. So no matter what the side lengths of the triangles are, sine of the same angle is always going to be the same because it's a ratio. Alright. So, SOHCAHTOA, a lot of you may not know this, but SOHCAHTOA is really just an acronym you use to memorize sine, cosine, and tan. Sine is opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. And tan is the opposite over the adjacent. So SOHCAH and TOA. Alright, so here are some more common angles that we're going to see, and these are the same angles that I'm going to try to use throughout the lesson because these are easy numbers to work with. So we're going to start off with the easier sine angles. We have sine of 30 degrees is 1/2, sine of 60 degrees is root 3 over 2, and sine of 90 degrees is 1. Keep in mind that sine, cosine, and tan are sine and cosine are never greater than 1, and if you move into precalculus, you'll find out why when you learn about the unit circle. So we have cosine of 30 degrees is root 3 over 2, cosine of 60 degrees is 1/2, and cosine of 90 degrees is 0. We also have tan of 30 degrees is 1 over root 3, tan of 60 degrees is root 3, and tan of 90 is undefined. And again, this is because tan of 90 degrees, this is equal to sine of 90 degrees over cosine of 90 degrees. So as we see here, sine of 90 degrees is 1, and cosine of 90 degrees is 0, so this is going to be undefined. Alright, moving on. Some more important properties you want to know is sine of 180 degrees minus x is equal to sine of x. Sine of 180 degrees plus x is equal to negative sine of x. Cosine of 180 degrees minus x is equal to negative cosine of x. tan 180 minus x is equal to negative tan
没
x.
有1个月还是可以整
Someone's
过的。
unmuted. You might want to check your microphone.
我在 focus。
You just
中
might
的
want to check your
focus 比
microphone.
去年的
Someone's
test
unmuted.
做的更
Okay,
差。
tan of 180 plus x equals tan of x.
当然没有。
All right, sine of 45 degrees is equal to root 2 over 2. Cosine of 45 degrees is equal to root 2 of 2 as well. And this is also because tan of x equals sine of x over cosine of x. So if we look here, using this, we can also find that tan of 45 degrees is equal to root 2 over root 2 divided by 2. So this is just going to equal 1. So I'm just going to go ahead and explain why this works. So when we have a unit circle, this means the radius of the circle is 1. All right, so, okay, I'm going to draw, let me open a whiteboard. Give me a sec. Okay. So when we have a unit circle right here, since this is in the xy plane, by the way. So this is the x-axis and this is the y-axis. This point right here, that's going to be 1, 0. And this point right here, that's going to be 0, 1. So as we choose an angle, this is going to be the angle that we choose. So if we say, for instance, sine of 30 degrees, well, the radius is 1. And so we can draw an altitude down here. And we find that since the hypotenuse is 1, this side is going to be equal to 1/2. And so this side is going to be equal to root 3 over 2, as this is a 30, 60, 90 triangle. So now if we're looking at sine of 30 degrees, that is, and let me switch colors. All right, so that is this side, this yellow side, over the hypotenuse. So we're going to get 1/2 over 1, which is just equal to 1/2. And again, the unit circle is also an explanation for why a lot of our properties work. We also have sine of 180 minus x equals sine x, and I'll explain that. So we have a unit circle as well. I should mention that sine of x is equal to the y value. So when we plot a point, any angle right here, let's call this alpha, and we draw an altitude down here, this is a point on the coordinate plane. So the x value is going to equal cosine of x. All right. So now with that in mind, if we have sine of an angle, let's say we have sine of 30 degrees. We can also draw sine of 150 degrees, which is just this entire thing. That's 150 degrees. And if we see here, it's symmetric. So we can flip this over the y-axis and get 150 degrees right here. And so this part is 30 degrees, technically. And so we'll see that since we just flip this over the y-axis, their sine is going to be the same because their y value is going to be the exact same. That's why sine of 180 degrees minus x is still equal to sine x. All right, so now I'll open up the presentation again. All right. So now moving forward, we're going to talk about the law of cosines. And this is really just a formula that's really useful to know in competition math. So the law of cosines is defined as, in a triangle, given two sides and the angle in between, the length of the third side can be expressed as the square root of a squared plus b squared minus 2ab cosine x, where a and b are the two sides and x is the angle in between. So what that's saying is if we have a triangle, this is side A, this is side B, x has to be this angle right here. If x is this angle, it's not going to work, so x has to be the angle in between the two. Alright, it's really just a formula. So now let's move on. Let's try an example. So we have in triangle ABC, AB equals 4, BC equals 6, and angle ABC equals 60. Find the length of AC. I'm going to give you guys a minute or two to try and solve this, but I'll give you a diagram here just to help. Once you get an answer or any sort of idea, just privately message me in the chat. Alright, I'll give you one more minute before I start explaining, but I see some good answers in there. Alright, I'll start going over this. So, first of all, we have a diagram right here. AB equals 4, BC equals 6, and a angle ABC is 60 degrees. This is one of the easier to work with angles. So now here's our formula for the law of cosines. The square root of a squared plus b squared minus 2ab cosine x is going to equal the side length of AC. So we can set a equals 4, b equals 6, and x equals 60 degrees. It doesn't matter which one we set as a and which one we set as b. Alternatively, we could have said that a equals 6 and b equals 4. But angle x has to equal 60 degrees. This is the important thing. Alright, so moving on. we plug these numbers in. So we get 4 squared plus 6 squared minus 2 times 4 times 6 times cosine of 60 degrees. And now we simplify this. So 4 squared is 16, 6 squared is 36, 2 times 4 times 6 is 48, and cosine of 60 degrees is 1/2. So we get square root of 52 minus 24, and that gets us 2 square root 7. All right, any questions? If not, I'll move on. Okay, moving on. Let's move on to the law of sines. This is also something useful in triangles, although instead of using cosines, it uses sines. So the law of sines states that in a triangle, given two sides and the angle opposite of those sides, sine of angle A over side length A equals sine of angle B over side length B, where A is the opposite side length A and angle B is opposite of side B. So what that means is we have a triangle. This is angle A. This is angle B. So opposite of angle A, this thing has to equal side A and this has to equal side B. And this has to be in a triangle. It holds for any pairs of sides and angles in a triangle though. Okay. So now let's do another example. In triangle ABC, BC equals 6, angle A equals 45 degrees, and angle B equals 30 degrees. Find the length of AC. So here's a diagram. I'll give you guys 3 minutes, about 3 minutes to try and attempt this problem. Just private message me if you have any ideas, if you need help, or if you have an answer. All right, I'll give you about 1 more minute and then I'll go over the answer. All right, so I see some good answers in the chat. Let's go over this. So here's the law of sines. Sine of angle A over side A equals sine of angle B over side B. Some people also prefer to write this as A over sine A equals B over sine B. And this works as well. They both work. It's the same thing. You'll get the same answer. All right, so we can set A equals 6. That's the side length we know. Angle B is 30 degrees and angle A is 45 degrees. It's important that we set it's important that we set A to 6 and angle A to 45 degrees since they are right across from each other. If we change the order, we're going to get a wrong answer. All right. So now you plug that in. A sine of 45 degrees over 6 equals sine of 30 degrees over AC. This little line over AC just means line segment AC. And so sine of 45 degrees is equal to square root 2 over 2. And sine of 30 degrees is equal to 1/2. Again, these are just some common angles that you'll need to know in trigonometry. Usually they're 30 degrees, 60 degrees, 90 degrees, and sometimes 45 degrees. So now we simplify this. Square root 2 over 12 equals 1 over 2 AC. And so we cross multiply and we find 2 square root 2 of AC equals 12. AC equals 6 over square root 2. And we have to simplify this since we can't leave a square root at the on the denominator of a fraction. So you can multiply both sides by top and bottom by square root 2, and this gives us AC equals 3 root 2. All right, are there any questions before I move on? Okay, let's try to practice this more. So number 4, we have practice and application. These are mainly problems that aren't so straightforward. The ones that I had in the examples were really just I give you values and you plug them in. These are ones you'll probably see more in competition math where it's not as straightforward, but you can still use the law of cosines and the law of sines to get the final answer. All right, so our first problem that we can practice is in triangle ABC, angle B equals 45 degrees and cosine of angle C equals AC over BC. Given that AB equals 4, find the length of BC. I'm just going to leave it as is right now. I'll give you guys a few minutes to try and solve this. If you still need help, I'll throw out a diagram on there, and then later I'll go over the solutions. All right, if anyone still needs some help, I'll just start on it right away. This one is pretty straightforward. The key in solving this one is this hint. Cosine of angle C equals AC over BC. So if we draw a triangle and we label it A, B, and C. Actually, let me draw it on the other side. Okay, so if we have a triangle, A, B, and C, we know that angle B is 45 degrees. And so it tells you that angle C is equal to AC over BC. So if anyone remembers from the lesson before, cosine of angle C, cosine is defined as adjacent over the hypotenuse. So AC would be the adjacent and the hypotenuse would be BC. So that implies that angle A is a right angle. And that's really the key in finding this, since I only give you one angle and one side length. And we also know that AB is 4. So if anyone wants to attempt this problem now, given this new diagram, give it a shot. I'll wait a few more minutes. Alright, so I see a lot more answers in the chat now. I think people are getting the hang of this, so I'll go over it. Alright, so yeah, the key in this problem is really just that cosine of angle C is AC over BC. This implies that angle A is a right angle. And so if you can't tell from here, since this is 45 degrees, this is a right angle. Angle C is equal to 45 degrees. Yeah, so we can also use the Pythagorean theorem. If you really don't want to use trigonometry here, it's fine. Pythagorean theorem states that AB squared plus AC squared equals BC squared. Because angle A is a right angle. Now, alternatively, you could have used the law of sines over here. You could have also done 4 over sine of 45 is equal to BC over sine of 90 degrees, which is angle A. And then you could have also solved it from here. I think in this case, the easiest thing to do would probably just be using the Pythagorean theorem, since it's very straightforward. And so, yes, the answers in the chat are right. BC is equal to 4 square root 2. Just also want to mention that a 45 degree, oh, I should probably draw this. A 45, 45, 90 triangle, it's one of the most common triangles you're going to see in competition math. It's where these two are 45 degrees, and this is a right angle. So if we have A, B, and C, from this we also find AB is equal to BC. And the ratios from these side lengths is going to be x, x, and x root 2. Another really common type of angle, triangle you're going to find is the 30-60 triangle. So if we have A, B, and C, let's say angle A is 30 degrees and angle C is 60. From this, you'll find that if this side length is x, AB is going to be equal to x root 3. And then AC is just going to be 2x. We can derive this from an equilateral triangle, where these are all 60. 60. And then we chop this in half. And that is how we get these angle measurements. That's just some extra stuff to know. Let's move on to the next problem. Does anyone have any questions so far? All right, good. I'll move on. So practice number 2. It says in triangle ABC, if AB equals 3 root 3 and AC equals 3, and angle C equals 60 degrees, find the length of BC. I'll give you guys a few more minutes on this one, a few minutes to solve this, and if we still need help, then I'll give you guys some hints. Alright, so I see that a lot of people are getting the right answer in the chat. I think I'll just start going over this. So the key in this is a diagram, a good diagram. So we have triangle ABC, AB equals 3 root 3, AC equals 3, and angle C equals 60 degrees. Find the length of BC. So in this one you can't directly apply the law of sines because you don't have this angle, you don't have angle BAC. But using this, you can probably find angle BC even without knowing what angle CAB is, because this is one of the special triangles that I was just talking about. So yeah, you can also apply the law of sines first. You can do sine of 60 degrees over 3 root 3 is equal to 3, sine of angle B over 3. And so upon simplifying that, we plug in sine of 60 degrees is equal to root 3 over 2. You can simplify this, and root 3's cancel on this side, so we just get 1/6 equals sine of angle B over 3. So we find that sine of angle B equals 1/2. And so we know that angle B has to be 30. Angle B could also be 150 degrees, but since ABC is a triangle, that wouldn't work since 60 plus 150 is greater than 180. And so since angle B, I should annotate this, since angle B is 30 degrees, we know angle A is a right angle, even though the diagram doesn't look like it. So now it says we can apply the law of cosine to find angle to find side BC. You could also apply the law of sines, or you could also recognize that this is a 30, 60, 90 triangle. But because I want to apply both, I'm just going to do the law of cosines right here. So I should probably say we are going to set 3 equal to A. B is going to equal 3 root 3. And the angle between them, x, this is going to equal 90 degrees. So we plug that in. A squared is 3 squared, B squared is 3 root 3 squared, and x is just 90 degrees. All right. So now we simplify this. Since cosine of 90 degrees is just 0, this entire part just goes away. So all we have is square root of 9 plus 27, which will give us BC equals 6. I'll also apply the law of sines here if anyone wants it. All right, so we have root 3. Actually, it'll be easier if we just do, 30 degrees and 3. So we have 3 over sine of 30 degrees. And this is equal to BC over sine of 90 degrees. All right, so what we can find from this is that sine of 30 degrees, this whole thing is equal to 1/2. And sine of 90 degrees, this is equal to 1. And so from here, you could just find out that BC also equals 6. Look at the same answer. There are multiple ways to solve this problem. All right, are we all clear on this? Oh. All right, so let me open up another slide on this one. Oh, I should probably stop sharing on this one. All right, let's represent. And so we have some extra information I can go over here. These are some more important trigonometric functions that you might want to know. And so we define sine of angle x as the opposite over the hypotenuse. Rather than just sine, we also have something called cosecant. It's abbreviated as CSC of angle x. This is equal to the hypotenuse over the opposite. Now we also define cosine of x. And this is equal to the adjacent over the hypotenuse. But we also have sec of x, second of x. And this is equal to the hypotenuse over the adjacent. So as you can see, between this, from here, we just flip the fraction. From here to here, we also flip the fraction. So we have CSC of x. This is just equal to 1 over sine of x. And the same can be said for sec of x. This is equal to 1 over cosine x. We also have tangent and cotan. So if we have tan of x, this is equal to the opposite over the adjacent. Now we also have cotan of x, which just like similarly before, this is all equal to the adjacent over the opposite. So it's just flipped. All right. Some other cooler things we can find. We have some more identities for adding and subtracting. So if we have the unit circle, this is really what explains most of the trigonometric identities right here. So the radius here is obviously going to be 1. So this is an angle, let's call it x. So now we can draw our altitude down here. And so we have this certain point. We know this part, this is the x value, right? Since this is an xy plane. The x value is equal to cosine of x. And the y value, which is going to be here in blue, this y value is equal to sine of x. And so since we know right here this is a right angle, we can apply the Pythagorean theorem to this, except for instead of saying x plus y squared, x squared plus y squared equals 1 squared, we can say cosine of x squared. Again, this just means cosine of x squared, plus sine of x squared. This equals to 1 squared. Since the radius is 1, it's a unit circle, which is just equal to 1. And from cosine x squared plus sine of x squared equals 1, we can derive a lot of other identities from this. So moving on, we also, let me just put another rectangle here. All right. All right. I'm just going to define a few other adding and subtracting formulas. These are ones that might be more useful as you get into like Amy level math. You might need these to switch a lot of functions on there. But we have sum and difference formulas. So if we have two angles, sine of A plus B, this is not equal to sine of A plus sine of B. This is an assumption, but this is false. This is actually equal to sine of A times cosine of B plus cosine of A times sine of B. The same can be said for subtraction. If we want sine of A minus B, this is not equal to sine of A minus sine of B. This is actually equal to sine of A times cosine of B. But instead of adding this time, we're going to subtract. So minus cosine of A times sine of B. So this is for sine. If you want to find cosine, let me switch colors. we have cosine of a plus b. This is a little different from the one in sine. This is equal to cosine of a times cosine of b. And this time it's going to be a minus sine of a times sine of b. Alright, so when we have cosine of a minus b, it's really the same except for this becomes a plus. I'll just write it on here in case anyone needs this for reference. So right here, instead of a subtraction sign, this is going to be a plus sign. All right, and lastly, tan. Tan works a little bit differently in this case, but I'll show it to you guys as well. So if we have tan of a plus b, remember tan works weird because tan is equal to sine over cosine. So this is going to equal tan of a plus tan of b. And then this entire thing is going to be divided by 1 minus tan of a times tan of b. And so the same can also be said for, let me make the rectangle a little longer. All right, there we go. So the same can be said for tan of a minus b. This is equal to tan of a minus tan of b. And then this entire thing can be divided by 1 plus tan of a times tan of b. All right, so those are just the sum and difference formulas. If you want to multiply angles instead of adding them, these are more special. Let me make another colored rectangle right over here. All right, this will be devoted to product formulas, sum to product formulas. That's what we call them. And so, you know what? I'll just give you guys the ones where we add and subtract them just as it is. These are ones that you're probably going to see very frequently in competition math, especially involving trigonometry. I'll also give you the double angle formulas. So these are actually particularly useful. If you want to find sine of 2x, this is equal to 2 sine x times cosine x. And the way we find this formula is by rewriting this as sine of x plus x, and then plugging that in to this formula right here. That's how we find both of these. We also have the double angle formulas for cosine. We have cosine of 2x is equal to, and there's 3 different forms for this one because sine squared plus cosine squared equals 1. So the first form that you see is cosine x squared minus sine x squared. Another form that we also see is 2 cosine x squared minus 1. And these two are equal because sine of x squared plus cosine of x squared is equal to 1. So if we want to interchange it, that's why. And lastly, there's a third form for this, which is 1 minus 2 sine squared of x. So these are the three forms that you'll see. You should probably get used to all three of them, as they can all come up in either format. And lastly, we have the double angle formulas for tan. And tan, again, is a fraction because tan works a little bit differently. So we have tan of 2x. And this is equal to 2 tan x over 1 minus tan squared x. All right, so these are our double angle formulas in the yellow box right here. In the blue box right here, we have our sum and difference formulas, and then the purple stuff up here is just defining cosecant, secant, and cotan. You'll also see these very commonly. One last thing before we end, I'd just like to mention is that you might see something called arc, and then arc sine. So this is actually not the same thing as cosecant of x. So if I say arc sine of 1/2, this is 30 degrees. And it's really the opposite of sine. So because sine of 30 degrees equals 1/2, arc sine of 1/2 is going to equal 30 degrees. And I'll write this here just in case it's easier for you to visualize, because sine of 30 degrees so whenever you see arc in front of a function, that means arc of whatever function equals something, and then you want to find what the angle is. So for instance, if I said, let me change to a blue, if I said arc cosine of 1/2, this would equal 60 degrees if I was talking about a triangle. Just because cosine of 60 degrees equals 1/2. So you can really think of arc as like the inverse, the opposite. When you have arc, you're trying to find the specific angle and not what its function is equal to. So it's 7:59. It's almost time to go. I just want to thank you all for a really great lesson today. Let me clear all my annotations. All right, I'll stay behind for a few more minutes in case anyone has any extra questions, and this link right here will lead you to future workshops. So yeah, thank you all for being here today.